Alright, so we're going to go ahead and get started in this lecture. This is part 3 of our Linux lecture series, and what we're going to be talking about today is service management. And there's really a whole lot that really plays into this, and it can be somewhat confusing when you begin to get into it. And so for one case, it's a good thing that we're doing this as a video lecture so that you can stop and go over it again and look at it and just make sure that you understand it. And then for two, I know that this is one of these things where you're going to want to practice it quite a bit. So you could really utilize this by watching the video and going along and using this through our NetLab implementation or your own virtual machine or whatever, so that you can actually practice this as you go through it. And so that's one of the very nice things about all of it. That's a little joke. It's hard to make jokes when I'm doing a video lecture, but I know that this PowerPoint can get a little kind of weird looking. So let's go ahead and just jump into what we're going to be talking about today in terms of services. And so we did talk somewhat about Windows and how Windows handles services, but we didn't really go very in depth into it. And one of the reasons for that is a lot of the service functionality is hidden behind the scenes or under the hood, if you will, in Windows, and we don't have to use it as much as we do in Linux. And so in Linux, we really want to spend really a whole lecture understanding how Linux starts and stops system services in order to accomplish a system task. Okay, so I know this may not make a lot of sense yet, but as I jump into it through this lecture, hopefully it will. So in the old day, before Upstart came around, and Upstart is just a name, but before Upstart came out, pretty much all Linux systems used what you see right here, the System V, some people say System 5, the System V service manager in order to stop and start services. And so let's go ahead and mention kind of quickly what a service is. A service is a background program, essentially, that is running on your machine that is going to give you some kind of functionality. So for example, I might have a service for my firewall. And so that is the service itself would potentially start the firewall when the machine starts up. It might turn the firewall off when the machine turns off. Or we could possibly even make the machine start with no firewall and then turn the firewall on based upon a service. And so that's kind of what we mean by services. So again, in the old days, all of this was managed by System V. The way that all this worked is with Runlevels, and we'll talk about what Runlevels are in just a little bit. I'll show you some of this, but not quite yet. But that is kind of Runlevels are what System V uses to handle starting and stopping and really the management of the services. However, today we are moving all Linux systems over to Upstart. Now Upstart is very nice because rather than being driven by Runlevels, which again I know that you don't know what those are yet, but rather than being driven by Runlevels, the new services that are run by Upstart are event driven, and this gives us a lot of functionality. But here's the big deal. As you see down here in this point right here, all the old System V stuff still works. And the reason that it still works is because in terms of what Upstart does, it hasn't yet encompassed everything that System V used. In other words, what's happening is right now, Upstart is going to eventually fully take over for all system services in Linux. But that hasn't happened yet. And so as programmers are migrating everything or porting, if you might say, everything over to Upstart, there are still some things that exist in System V that are still active and still used currently on a modern Linux system. So in other words, we still have System V, and we still need to teach it because you need to understand how to use it. Eventually, maybe a year from now, 5 years from now, maybe even longer than that, everything will get moved over to Upstart completely. So I mentioned this earlier. Upstart itself is event-driven. So what this means is it gets triggered when something happens on the system. So it could be, for example, maybe a service is required for a program to run and it's not. Well, that could generate an event, and Upstart would see the event, and Upstart would go ahead and start the required service. So I hope that makes sense. There's all kinds of events that can happen on the system to require a starting or a stopping or a restarting of a service. But typically there are things like a program calls for it, maybe the machine is being shut down or it's being powered on, things like that. Those are kind of the common ones. So that's kind of what we mean by event driven. Now all of the Upstart scripts themselves are right here in etc init. Now I'm going to show you this in the next slide right here. I've done a print working directory command in etc init. Okay, so you see this right here. And then here's what it's going ahead and it's showing me. These are all of the these are all of the scripts, the configuration scripts for Upstart services. Okay, now I know that very few of these, if any, will make sense to you, and I'm not interested in this lecture about going through any of these in depth or even at all talking about what they do. I just want you to see that in Etsy Init, this is what you need to know. In Etsy Init is where all of our Upstart scripts are. So again, these are all driven by by events with Upstart. Okay. Now let's go ahead and take a look at this. This is going to be somewhat difficult to understand. But this slide is really nice because it shows a flow chart of how Upstart works and then also how SysV stuff still works. Because remember what I said a couple slides back. Let me go back to this. SysV is still in use today. Upstart is eventually going to take over for it, but it hasn't yet. So the two work hand in hand. Eventually, everything that you see here, all this stuff in yellow, which is SysV right here, eventually all of this will be done through Upstart as well, but it hasn't happened yet. Okay, so let's kind of go through this really quickly. Here's what's going to happen. At some point when the kernel starts up, when the machine boots, we get an init or an initiation. Okay, and there's a lot of things that happen through here, and I'm going to go through just a couple of them so you'll understand what might happen. Okay, so when we go into an initiation right here, the process ID of 1, what's going to happen is the Linux system is going to read the configuration for both the Upstart-based stuff and the old legacy SysV stuff. See this here? So we actually have two sections that the machine initially branches into. On the first section, let's go ahead and talk about the old legacy SysV stuff because this is a little actually easier to understand. Okay, so when the machine starts up, it reads the configuration to say, hey Upstart, the computer asks, hey Upstart, how do I operate? And hey SysV, what stuff do I need to start or stop? Okay, so those are the first two things it does, and it finds it out from the configuration files. For example, these are configuration files. Okay, this is for, I went back a slide, this is for the for Upstart. Okay, so it reads up what's in each of those directories, everything in Etsy Init, and then it also reads what's in here, Etsy Init and then rcsysinit.conf. Okay, so again, you don't have to memorize this big long one right here, but we are going to talk about it. Okay. So anyways, we read it, the system reads up configs in Etsy Upstart and SysV. And then what it's going to do, let's talk about SysV first. What it's going to do is it is going to, in most cases, go over here and look and say, what startup level am I running at? Now, I haven't talked about startup levels, but remember I said earlier, let me go back a few slides. Right here we were talking about Runlevels. Well, we're about to talk about Runlevels, and one of the things it's going to do is when it starts up, it's going to go and look and see what run level I'm in. Now, a run level basically tells the system what is happening on the system at this time. Is the computer starting up? Is the computer shutting down? And there's all kinds of different run levels that exist, and I'm going to show them to you in a little bit, that dictate to the computer how it starts up or how it shuts down. Okay, so what it's going to do is this S right here is actually a placeholder. So if you're used to algebra, this might look like an X or a Y, you know, if you're used to that, but this is just a placeholder. So it's going to go and it's going to look up and it's going to say, okay, I am in run level 5 or run level 3. I'm just throwing those out there right now. And depending on what run level it is going to go and it's going to look up and see what's in Etsy init.d and then rc and then again that run level.d. Okay, so remember we sub this letter right here for a number, the actual run level it is. Okay, and then what it's going to do is it's going to go and it's either going to start or it's going to stop, and maybe both different services that are in here. Okay, now I know you are scratching your head saying, what are you talking about? This is really difficult to understand until you see it in action. So I'm going to show it to you in action in just a minute. Okay, but bear with me. So with SysV, let's go over this one more time. Everything starts up with a run level, RC1, RC0, RC2, RC all the way up to RC6 are different run levels. So depending on which run level it is, it goes into a specific directory, Etsy init.d and then RC, and then there's all kinds of different run levels, subdirectories under init.d for the run level. And then whatever is in this directory, it actually loads it. It starts it or it stops it. Okay? Now, this right here is changing run levels. I'll mention this more later, but what I can do on the system is I might be in, let's say, run level 3, and I might need to switch to run level 5. And again, we haven't talked about why you might do that, but just know that you can. So in that case, the user himself or herself can execute a run level change. And so that's what this RC is saying right here. So we do RC, and then we tell it what run level, and then it would go, and just like it does over here, it would look up and see what's in that run level, and it would start or stop. So in other words, here's what's happening. When the computer starts up, it starts in a default run level. However, if I want to change the run level, I can do that with the RC command. Okay, that's kind of what we've got going on here. Now, let's go ahead and look over at the event stuff. This is actually, it's the way the flowchart's showing, it's actually pretty easy to understand. So when the machine starts up, it does do all this stuff right here in SysV, but then it needs to go over here, and it needs to look up and see what's in the etsy init directory. Okay, and remember what we said here, this is all Upstart stuff, right? So this is all based upon, it's all based upon events. So what might happen is, based upon a condition or an environment or an event, it's going to start or stop a service. See how this works right here? And then once everything's actually running are when these events can start or stop or change a service. So for example, it gives some examples. If hardware is added or removed, so for example, if you plug in a USB thumb drive or maybe a microphone of some kind, that's an event that the system might need to handle. Also, if a task is started or stopped, so I bring up a new program or a task that requires some service that's not started, well, that's an event that might get generated. Okay, and then also, just like SysV stuff, there can be changes. If I start the machine, I shut down the machine, or I change run levels. Even the stuff that I might do over here, starting, stopping, changing run levels, may affect some of the stuff over here in Upstart. Okay, some of the Upstart driven stuff. All right, so in other words, if I could draw a line right through here, in fact, I think I can. Let me bring a pen up. If I draw a line right through here, this all of this right here is SysV. All of this stuff right here is Upstart. They both run hand in hand. They're running at the same time. Because notice this, right here, when, let me change my pen color here. Let's go to yellow. When the machine starts, it reads the configurations for both what's here in Upstart and SysV, and it does them both at the same time. And things that we might do here in SysV may end up affecting, well, really, because all three of these, they may end up affecting what's in Upstart. All right, so I hope that makes some sense. Okay, so one of the problems that we have with Upstart is, again, it's new. So I talked about this just a little bit. It doesn't support everything. That's why we have this big convoluted script right here, or flowchart, that shows what stuff is handled by SysV and what stuff is handled by Upstart. So eventually this will all begin to make a little bit more sense once everything gets moved into Upstart. But that, again, is going to be a while. So like we said, everything in CentOS is still using all the old SysV stuff. All right. So I'm going to show you where a lot of these scripts are located. And by the way, this right here, some of this is going to be different depending on what version of Linux you're using. For example, etsy init rc sysinit, and then etsy init.d. Some of these directories right here may look different if you're not on CentOS. Some distributions of Linux will put these in different directories. You might just get used to experiencing sometimes they're not exactly how you might look in a book or in any documentation. Okay. So I'm going to show you this in just a second, but all the SysV stuff is located in etsy, rc.d, init.d. Okay, these are where all the actual scripts are. These are what I typically say in a lecture is where the raw scripts are, and you'll understand why I say that here in just a second. But here's the deal. All of the scripts that are in etsy, rc.d, init.d, everything that's in here are actually not run from those directories themselves. They're actually run in a different directory, and I'll show you why. Okay, but before I show you why, let's talk about run levels, because you're going to need to understand each of these run levels, and then I'm going to bring up a Linux system. I'm going to show you some of this stuff. Okay, so we have run levels in Linux, and remember, this is all SysV stuff. We have run levels that range from 0 to 6. So in other words, we have 7 available run levels. Okay, run levels 0, 1, and 6 that you see here. These are the kind of what I call the special run levels. If we go to run level 0, that would shut the computer off. Okay, so again, that would assume that the computer is actually running, right? If we go to run level 6, that's actually a reboot. Now, the difference between 0 and 6 is simply this. Run level 0 turns the computer off and it doesn't come back on. Run level 6 is a reboot or a restart, so it shuts the machine down and it immediately boots back up. So you guys should understand the difference of that by now, I'm sure, in your course progression. And then run level 1 is different. This one's really weird because it's called single user mode, and I'm going to talk a little bit more in the next slide about single user mode and why it's really powerful but really dangerous. And then also in lab, we're going to go through run level 1, and you're going to see the power of run level 1 as well. So those are our special run levels. 0 is off, 6 is reboot, and run level 1 is single user mode. Now let's talk about the others. Run level 5 and 3, and I know I'm doing these out of order, but run levels 5 and 3 are the ones that you'll commonly use. Run level 5 has your graphics, and the version of Linux I'm running right now has graphics installed, and so I'm currently, when I show you my machine in a second, it'll be run level 5. Run level 3 is text mode only. In other words, it's Linux without graphics. There's no GNOME, no KDE, no graphics implementation at all. And then run level 2 is text mode, multi-user, but no network support. In other words, it's kind of like run level 3 and run level 1 put together. In other words, it's text mode, just like run level 3 is, and it allows multiple users, which run level 1 does not do. And it also has no network support. So run level 1 and run level 2 don't have network support at all. So if you just need, and again, it's rare you'd actually have to go into run level 2, but if you just need text mode and multi-user with no network support, that may do the trick for you. And again, it's very rare that you would need that because of the reliance we have upon network support. So run level 2 is not used very much. And then run level 4 is not used at all. It's just been reserved in case we need it for another purpose later on in the future. Okay, so those are our run levels. Okay, so let's go ahead and show how some of this works, because what we're going to go ahead and see in all of this, as you probably have no doubt already realized, is that this can be really difficult stuff to understand until you actually see it in action. And so that's really what we want to go for right now in this part of the lecture. So I'm going to go ahead and log on to this machine. This is a virtual machine running on my laptop, so it's very similar. It may not look exactly like your machine does in lab or a NetLab implementation, but it's very, very similar. So currently I am in a graphics implementation. So you've got Firefox, I've got my computer up, all that good stuff, right? So that means if you were to go back and look at the lecture earlier in a few minutes back, you'd see that I'm currently run level 5. And that should be obvious because I've got graphics. So what I'm going to do, I'm going to show you just a few things as we go through all of this so you can get an understanding of where we're at in all of this. So you can see right now, if I type the command run level, we can see that it shows that I'm started and I'm in run level 5. See how that works? So it's one quick way to see what run level you're in, although usually it shouldn't even be necessary, simply because if you've got graphics, you're in run level 5. If you don't, typically, and you got network support, you're run level 3. So it's generally pretty easy to understand. Okay, so what we said was that all, in fact, I'll just go in here. All of the run level stuff, oops, I'm sorry. This is what I get for trying to type and talk at the same time. All of the information and service scripts are all in Etsy, in the Etsy directory. So first of all, in Etsy init, all right, let me clear this. So currently I am in Etsy init. See this right here? So if I were to look in here, we see all of our service scripts. See all these? So just like I showed you earlier, let me stretch this out a little bit more. So just like I showed you earlier in the slide that I had actually embedded in the PowerPoint, you see all of the service scripts that are associated with Upstart. And again, you don't have to know all of these, but you can look at any of them and you see this one actually is pretty short because the other one is longer. It's the rcs.conf right here. This one is actually far longer. So anyways, again, you don't have to understand all of this, but these are all of the Upstart related information for Upstart. And as we said, if you go back and look at that flow chart, this right here is all of the is only for Upstart. But running at the same time is all the SysV stuff. Remember we said it's over in cd space Etsy rc.d, and then it's in init.d. So first of all, I'm just going to show you what's in the rc.d directory. So currently we're in Etsy rc.d. So if we do an ls in here and we look, notice what we see here. We've got some kind of init directory, an rc script, and we know that's a script because it's green. Same with this. This is a script because it's green, and this is a script because it's green. If you don't believe me, let me do an ls-l, and you see this. See how right here we have a dash right here at the very beginning at the indicator, so we know that's actually a file. Whereas all these ones in blue, notice they all start with a D. This is a little bit of a review before, but you can tell these are directories. And the reason that these are green instead of black, because if you remember, black is a typical file. The reason these are green is because look at these. They have the execute bit set. right? So these are actually executable files, hence they're kind of a light green. So anyways, going back to all this, let me bring this back to the top of the screen. Okay, so we have a few directories here, and then we have 3 actual initiation scripts. So if you look at this, RC0, RC1, RC2, RC3, 4, 5, RC6.d, all of these, if you look, it's pretty easy to tell what these are, right? These are run levels, right? Each of these directories are a private directory specifically for a run level, okay? But remember how we said all of the raw scripts I said were in this directory, right? In etc rc.d, init.d. So let's go there real quick. We could just do init.d since we're currently in the rc.d directory, but just to make sure this makes sense for everyone, I'm going to go ahead and specify the hard path. So etc rc.d, init.d. Okay, so this will take me into this directory right here. Now let's go ahead and look. Notice we have many, many more scripts than Upstart. See this? The reason is because there's still a lot of things that have not gotten moved over to Upstart yet, and it may be a while. So this is why we still need to teach all the SysV stuff. So again, these are all the raw scripts. So let's go ahead and look at one. Since we've been talking about the firewall script, let's look at that real quick. Here's Iptables. This is our firewall. And again, you don't have to know what Iptables does. We're just going to look at it as an example. So we begin to start the script. It's a shell script. Here's some basic information. Anything that's starting with a comment, except for the first line, but everything else that starts with this pound sign, not a hashtag, sorry, it is actually just a comment. So the screen actually doesn't read them. It's just for your information when you read through it. So we can see this is all the information that's needed to start the firewall. And notice there's quite a bit, right? If you've never looked at bash scripting at all, this might look like crazy mumbo jumbo to you. If you've ever looked at it, you'd actually know, bash scripting is actually pretty easy to write and read. But this is everything that's required to start Iptables. So I'm just going through all this so you can see it's quite a bit of information, isn't it? Okay? So going back out of there, these right here, everything in green, with the exception of this functions right here, everything else here are all scripts for SysV to start and stop everything. Okay? So again, like we said before, everything, all the raw scripts themselves, everything you see here is in etc rc.d, init.d. But again, here's the difference. Everything that is in this directory is not run directly from here. These are just where the raw scripts themselves exist. Okay? Now you might ask why. Well, let me explain why. Let's go up a directory. So now we're back into this directory I had up here, this rc.d directory. And let's look at it again. Okay, I'm going to clear the screen and let's look at it again. So we were just in here, we saw all the raw scripts. But remember how we said that you have specific run level directories depending on what run level we're in? And currently we're in run level 5, right? So let's go in there. Let's go to rc5.d. Now here's where this is hopefully going to start making sense to you. Okay, I'm going to do an ls. First thing you notice right away is they're kind of that bright blue color, right? Which if you remember from one of the earlier lectures, these are links. In other words, these are not files themselves, they are soft links that point to somewhere else on the system. The second thing that you'll probably notice is they all start with a K or an S. You see this? And then a number. The third thing you'll notice, if you have a good memory, and you may not, and that's okay, but if you remember, a lot of these look like everything that you saw in init.d. And guess what? If we do a long listing, the reason for that is because they are. Look at this. Remember how we said the reason that they're light blue? Well, now I'm doing a long listing, so instead of just shoveling them all to the screen one after another, I'm doing a line listing of each one. So notice that these are links. See this L right here, this indicator? So it says it's actually not a real file, it's a link. And the link itself, for example, K01 smartd actually points to init.d smart.d. I'm sorry, I cannot talk, init.d /smartd. There we go. Okay? In other words, again, this right here, this script right here that is in this directory right here, rc5.d, this file actually points to this directory, see this, and the smartd in there. And so does everything else. See how all of these are actually links that point to here? In other words, here's what we have. These right here are the same files as what you have in here. The only difference is they have a slightly different name. K01, K05, so on and so forth, and some are S11, S12, S13, so on and so forth. Okay, so let's talk about all this. First of all, we said these are links that link back to the actual real initd directory. This is where the raw scripts are. Everything in the RC and then run level directories right here, everything in there are actually links to what's here in initd. Okay, so we understand that. Next, why do they have a K and an S? The reason they have a K is because the K means it's a kill script. The S means it's a start script. In other words, here's what would happen. If my computer switched to run level 5, for example, when it boots up, right, when it starts, what it does is if any of these services, SmartD, WDaemon, SAS, I don't even know what that is, Sassalofty, HTTPD, so on and so forth, if any of these with K are currently running, what it does first is it stops them. Now, it may be that those scripts are not running. If they're not running, if the service is not running and it tries to kill it, then it doesn't have anything to kill, it just moves on. Hope that makes sense. So these are just kind of in case. In case any of these happen to be running, it will kill it, okay? And then if it's not running, so for example, if CG red is not running, then it just moves on. So it's just kind of a backup. And then what it does is after the K's have been run, then it starts the S's. And everything with an S, like I said before, is a start script. So it would start this service, it would start this service, it would start this service, okay? And then the last thing to understand is the reason that these are all have numbers in front of them is so that we can have an order by which we start or stop a script. So in this case, snort is the last thing to load. What if I needed it to load before, let's see, SSHD, okay? Well, what I would have to do is I'd probably need to move it to like S, for example, 51 snort. See how that, and then alphabetically, see how it would go in between Bluetooth and SSHD? It would go right in between that, alphabetically speaking. So these numbers are simply so that we can alphabetically, and really I should say alphanumerically, sort our scripts to run at a certain time, because we may need cups to run before, let's say something that starts with an A, right? I'm not seeing anything on here. For example, before abort CCPP. See this? And it does. The reason we can maintain that is because if we didn't have a number, then it would be impossible to make it run before it. But since we put a number in, S25 comes before S82. So that's what the numbers are for. They're to alphabetically sort. So let's go through this again one more time, just to make sure we all understand this. In the etc rc.d directory are run level scripts 0, 1, 2, 3, 4, 5, and 6, and those contain links to the init.d directory. Okay, and if we look in, I'm just going to list it right here. If we look at the init.d directory, we see that these are actually all the raw scripts that we were just talking about. See this? There's the abort one we were just looking at. There's auditd. Iptables is in here somewhere. So on and on and on. You see how all of these exist and work. And then in every single one of these directories, let's look at RC3, for example. It's going to look very similar to RC5. Here's all the kills and here's all the starts. Okay, so this is how a computer gets from one run level to another one. Okay, now most of this happens when we start the computer or stop the computer. So if the computer is not running and I boot it up, in my computer's case, it will go into run level 5 automatically. So what it does is when the computer gets ready for it, it looks and sees everything in run level 5, and the first thing it does is it kills in case anything happens to be running, which typically it doesn't. It would kill anything currently running with the K scripts, and then the S scripts would start everything up. And then all the other run levels are exactly the same. So let me illustrate this for you. Let's by hand or manually switch run levels. So we can use the init command. So I'm going to switch to run level 3. What this is going to do is it's going to go right in here, see? And it's going to kill any of these things that happen to be running if they are. If not, it moves on. And then it's going to start everything that's in each of these. Okay, so let's watch this in action. Well, I guess I need to be root first. Okay, so we're going to init 3. And notice the computer immediately kills out my graphics. And look at this. I'm in run level 3. Now let me illustrate this or prove it to you. Okay, so now I'm logged in as root. Watch this. We can do run level. Look at that. I'm in run level 3. And I still have full, well, I don't know if the machine's set up for this or not. Yeah, it is. So I still have full connectivity because run level 3 contains all of that. Okay? So let's go ahead and switch back to init 5. If I do that, remember what it's going to do. If I go and look in etc rc.d, what it's going to do is it's going to run everything that is in rc5.d you see right there. Okay, it's going to go in, it's going to look at rc5.d, and it's going to run, it's going to kill all the stuff with k, and it's going to start everything with s. So init space 5, it's killing everything with the k's, and then it opens everything with s's, and there we go, we're logged in. Or at least we got graphics. Let me log in real quick. Okay, very good. So one other thing I want to show you as we move through some of this is, let me go ahead and, oh, now it's full screen. Sorry about that. Don't know why it did that. I hope you can still see it on the lecture. So now what I'm going to do is I'm going to go ahead and do an init, and let's do a reboot, so init 6. Okay, I want you to see how this works. So, got to be root again, sorry. Okay, so now that I'm root, I'm going to init 6 and watch what it does. Very similar to when we switched to run level 3, the only difference is this is actually restart run level. So watch as it restarts. And here it goes. So now the machine doesn't have a run level at all. Okay, so Linux is actually running. And what it does is it starts up some core stuff, and then very quickly it begins to go and look in the run level, and now it's doing it. And it goes and sees, okay, I'm run level 5 default, and it loads all the stuff you just saw there. And I know it went super quickly. You don't have to understand it all, but just know that's what it did. Okay? You log in one more time. And then there's one other thing I'm going to show you. I'm going to show you this now, and then I'm going to talk about it in the PowerPoint in just a second. Okay, so remember how we talked about the fact, actually I got two things to show you, okay? So remember the first thing I want to show you, remember how we talked about the fact that everything, that it goes into a default run level when the computer starts up? Well, here's how it knows what run level is default. If we go and look, there's a file, I'm going to open it, it's called etc init tab, okay? Well, the file is called init tab, and it's in the etc directory. So if I look at this right here, it does a few different things, but the main thing it does, look at this, it says ID5 init default. So for my computer, run level 5 with X11 is what this is called, is actually the graphics daemon that runs. This right here, run level 5, is actually how the computer knows to start with graphics. See how this works? If run level 3 was set, in other words, if this right here, let me go down to it, if this 5 were a 3, right here, then when the computer starts every single time, it goes into full user mode. I'm sorry, full multi-user mode without graphics. Does that make sense? So just like we talked about each of these run levels, this is how the computer knows which one to go into. And if you want to ever play a funny joke on someone, see how it says do not set this as a default for 0 or 6? Well, there's a reason for that. If you set that as a default, then for example, let's say 6, then here's what happens. Every time the computer starts up, it goes and looks in this file and says, okay, what's my run level to start? And it says, oh, run level 6, great, I'm going to reboot. And the computer reboots. And it starts up again, it goes and looks at the run level and init tab, and it says, what's my run level? Oh, reboot. I hope you get the point. It just continuously reboots. Now, it is possible to bypass that. I'm going to show you that in a second. But just be aware, if you ever want to play a funny joke on someone, you can set their run level to 0 or 6. And if they're not very aware of Linux services and how everything starts and stops, they're going to be pretty mad at you. So I'm going to go ahead and quit out of this. I'm not going to save it and keep it as run level 5 as a default. In fact, I wasn't root. I wouldn't be able to save it anyways. Let me switch over to root real quick. Okay, so now that I've switched over to root, let me show you one other thing. Let's say I have forgotten my password. Remember how we said run level 1 is single user mode, no network support at all? Let's say I can't remember root's password. Now, just like Cisco does, just like Windows, there are mechanisms we can use to reset our password. And I'm going to talk about this in the PowerPoint, but I'm going to go ahead and show you this now. So let's say I tried to turn my computer on and I cannot remember for the life of me what my password is. I tried to log in, and I can't. I can't remember root's password. Well, here's what I could do. I could, let's say I just restart the computer. In fact, you may not even have login access. In fact, let's just do this. Let me log in. Because it's not going to make a lot of sense unless I show you this. I'm going to go ahead and quit out of this session. Okay, so let's say I've been trying to log in as me and I can't remember my password. And I'm trying and I'm trying and I'm trying. I'm like, darn it, I cannot remember what my password is. Or maybe I've tried to log in as root and I don't remember what the password is. Either way, if we get stuck, here's what we can do. We can just restart the computer and watch what we can do. This is really neat. What you do is, as the computer begins to run, in just a second, once it restarts, here we go. If you quickly hit a button before it loads, well, I hit it twice. I'm going to have to bring this back up again. Let me wait till this comes back up and restart it. So while it's going, let me explain what we do. You can hit a button, like the up button, for example, is the best button to use. You can hit it really quickly. And what it does is it brings up your Grub menu before the computer starts. And you remember what Grub is. We talked about Grub earlier. Grub is our bootloader. And we can pass to Grub, we can force Grub to load a different run level than what's default in its init tab. Does that make sense? So watch, we're going to do this. So I hit a button really quickly, and now notice I have my Grub menu up. Okay? So here is the only operating system Grub sees, my CentOS box, which is correct. So if you look down here a little lower, I don't have my mouse able to show you any of this right now, but if you look, you see it says you can press E to edit these commands. So what I'm going to do is I'm going to hit E on this string right here. So hit E, and then here's what it brings up. It brings up the boot line for this CentOS Linux it found. First of all, it's showing it's in hard drive 0 and partition 0 is where it is. And then it shows you the kernel string that it passes to start the kernel, and then it shows you actually the image of the Linux kernel itself, or actually RAMFS, sorry. Anyways, so the line right here, if you want to pass a custom run level to it, here's what you can do. We already hit we hit a button when we were right here. When Linux was booting, we hit a button like the up button really quickly to start and to go to pass this string to Grub. So then once we're here, we hit E to edit, and then you go to your kernel string. You hit E to edit this line. So in other words, we've hit E twice. And if we look, here's the big long string. I'm scrolling left. Here's the big long string it uses to actually boot the kernel. Okay, so this is the actual kernel right here, VM Linux 2.6.32. i686, read-only, root, there's the UUID for him, and lots of other stuff we're not going to go through right now. And I'm going to go to the very end. And what you can do at the very end is you can put in a number, like a 1, like a 5, like a 3. And what that does is that tells the computer to manually boot into a specific run level and to bypass whatever the default is from init tab. Okay? So let's run it. Let's force it to load into run level 1. Okay, so I hit 1 and then I type enter, hit the enter button, and then what I do is I need to boot this custom kernel right here. So I hit B to boot it. So watch this. I'm going to hit B, and now what it does is Linux loads just like before. The only difference is when it goes to the section where it looks and sees what my run level is, it loads run level 1. Now, if you're familiar with Linux, what did it automatically do? Who am I logged in as? I am logged in as root. You see this right here? And I didn't have to authenticate. This is very scary, and this is also very powerful. This is Linux's password recovery mechanism. When you load into run level 1, it automatically gives you root access. Now, I don't have network services. I can't do anything. I can't ping Google. I can't hack the box, so to speak, either by uploading like hack tools or something like that. But what I can do is I can change root's password, or anybody else in the system for that matter. So I'm going to change it to another weak password. Okay, so look at this. So I have now changed root's password. See how that works? Very, very dangerous. And here's why this is so risky and why you need to be aware of this, is because if a bad guy can ever get physical access to your computer and he can force it to boot to run level 1, then you're in trouble. You're in trouble because he can just automatically get root access. He can change root's password, and then watch what he can do. He can just switch to run level 5 right from this screen. And while it's loading, I'll go ahead and talk. And so while it switches up to run level 5, it gives me graphics. And now remember, I've changed root's password, right? So now what I can do is I can log in as root or any other user I changed the password for. So let's go in as root. And I'm going to go ahead and put in his password. And then it's giving me a warning about logging in as root. But anyways, now I'm root. See that? So if this is a mechanism for a good guy or the administrator of the system in case he forgets the password. But it's extremely risky because for a bad guy, if he ever gets physical access to your computer, he can change root's password. Now, there are a couple mechanisms we can use to help prevent this, but nothing is foolproof. In other words, what we really need to do to protect ourselves is make sure people don't get physical access to computers, especially servers. This is why we put servers in locked rooms with cameras, with biometrics, with ways to make sure that we can authenticate who actually gets into the server room. Because anybody that has physical access can potentially reset root's password and get access to the box itself. Okay, so that's kind of a quick tour through Runlevels. Hopefully all that makes sense. I'm not going to recap all of that because you can just hit the rewind button or just track backwards through the video to kind of see all of that again. Okay, so now what we're going to do is we're going to go ahead and jot back over to the PowerPoint so that we can finish up on this lecture. Okay, so looking back at this, we talked about each of these run levels. And this is why run level 1 is scary, like we just showed you. Remember, we get root access to the computer without a password in run level 1. And the third immutable law of security, in fact, there's 10 immutable laws. You can Google them if you want to see them. But the third law states this: if a bad guy has unrestricted physical access to your computer, it's not your computer anymore. And this is absolutely true. Even with full disk encryption, it is still at risk. Therefore, as I said before, make sure that bad guys don't get access to your computer physically. This is why we SSH to them, because if I SSH to a computer, I can initiate a restart, but the second I initiate a restart, I lose my secure connection to the computer itself, so I can't actually force it to go into a different run level and change root's password. This can only be done at the actual computer screen and keyboard of the physical computer itself. This is why we keep physical access away from as many people as possible. Now we looked at init tabs, so I'm going to skip by this because we're pretty familiar with this. We've talked about all of the run levels, so here's some more graphics for all of this. So you see it just like we've seen before. This is just a screenshot I showed you. And then again, we talked about the fact that these are links, so they all link to the actual etc rc.d init.d directory. I'm showing you this right here with the arrow. We talked about switching run levels. Okay, now here's some new stuff. What happens if we need to change our system, right? As you saw, all the stuff that you saw right there in the Linux example I gave you were default. That's the way it started up. But what happens, think about this with me, what happens if we don't want things to be the way that they're set up by default? What if we need to change it? What if we don't want something to start at run level 5 that's currently started, or vice versa? Well, this is where chkconfig comes in. What the chkconfig command does, and I know you have to watch the spelling, it's CHK and then config. They spell config normally, but not check. They don't like the E and the C in the middle. Again, I don't know why. Anyways, so if you look here, the check command can be used to turn a service on or off. And it can be used for specific run levels. So in this example, we have chkconfig httpd on. And what that would do is it would turn the service called httpd, which is actually the Apache web server. It's not important you know that. But what it does is it would turn that on for run levels 3 and 5. Because we didn't specify which ones. We just said turn it on. So it makes sense logically that we would turn it on, not for all run levels, because you wouldn't want to turn something on a restart run level like 0 or 6, right? So when we do the on command, it would turn it on for run level 3 and run level 5. In other words, if the computer were off and we started in run level 3, it would turn it on. Or if we were in run level 3 and we turned to run level 5, it would make sure the httpd stays on. Hope that makes sense. So here's how we can do some of this. All right. First of all, remember how we said that everything is each service that needs to start up at a run level is going to be a link in the actual run level directory. So for example, if we're talking run level 5, then that script will actually be a link right here, rc5.d, that points to etc rc.d init.d. Remember we talked about all this. That's what the S for startup is. So if we need something to start at a run level, it's going to have to be in the run levels directory with an S in front of it. Okay. If we want it to stop at a certain run level, then the same thing, except it needs to start with a K in front of it. Okay, and so this is what all of that, we've talked about this, but just to review to make sure you're understanding this. Okay, so in a second I'm going to show you how that works on the system. I'm actually going to show you a couple examples of that. Okay, but we can also start and stop a service manually. Remember, everything, I'm going to go back a slide, everything that we're talking about right here to change for run levels only goes into effect when we actually switch into or out of that run level. So if I turn Iptables off for run level 5, then the only time it would actually turn Iptables off itself is when I switch into run level 5. I hope that makes sense. But it doesn't actually turn Iptables off right here and now. Does that make sense? So there's two things we're talking about here. One, if we want to turn Iptables off right now, this will not work because this is for run levels. This is for when the computer starts or when the computer stops, or in other words, when a computer goes into a run level or out of a run level. But what if I need to change the firewall right now or change another service right now? Well, then, like I said, number two, the second thing that we need to say is we need to look at the service command. Because what the service command does is that manually starts or manually stops a service right now. Okay, I hope that makes sense. So we have a distinguishing difference of two things. The chkconfig command and everything we do with the run levels that we've been talking about are only for starting and stopping run levels. That I could have it stop at run level 5, and if I'm in run level 5, it doesn't actually turn the firewall off until I go back into run level 5 again. I hope that makes sense. What if I need to turn the firewall off right now? That's where the service command comes into play. So service, and then we give it the name of the command. This corresponds to the actual script, the actual name of the script that you see in etcrc.d init.d, and then we tell it start or stop. Okay, and what that does is it actually stops or starts the service right now as we're working. Okay, so the RC stuff is used for inits, for starting and stopping run levels, but the service command is used to start or stop a run level right now. So I'll show you this in just a second. Here is a big long list of some of the services that exist on your system, and I'll show you this in just a minute. Okay, but notice on the system, on the Linux system, but notice we have each run level listed in a column 0, 1, 2, 3, 4, 5, and 6. See this? And then what we show is, for example, notice that everything in run level 0 is off and everything in run level 6 is off. This makes sense because those are shutdown run levels, right? 0 shuts it down and run level 6 restarts. So it makes sense that every service that would ever exist in the system needs to be a kill script, needs to stop for those run levels, right? Because we're shutting the machine down or rebooting the machine. But then for run levels 3 and 5, which is what we really want to focus in on, notice that some of them are on and some of them are not. So for example, DC client is off for run level 3 and run level 5. What if we wanted it to be on? Well, regardless of what it does or doesn't do, notice that these are off, so we might need to switch them on. Same thing for cups, which is our printing daemon. 3 is on and 5 is on. In other words, when the computer starts up into run level 3, it turns it on. When it starts up into run level 5, it turns it on. So by way of example is what if we turn our computer on right now and went into run level 5? Is cups running? Your answer should be yes, because run level 5 says it's running. What if we want to turn cups off right now? Well, if I turn this to off right here, it actually doesn't stop cups until I go back into run level 5 all over again. In other words, the next time I reboot. If I need to turn cups off right now, I would have to use the service command. Okay, I hope that makes sense. So let's go ahead and bring some of this up, all right? Here's our Linux machine, and let's go ahead and look at some of this stuff, all right? So we're going to look at the chkconfig command, okay? I just ran chkconfig, and notice it gave me a big long list of everything that's running, all right? So we've been using Iptables as an example, so here it is right here. There's two IP6 tables, that's for IP6. We're going to talk about this one, Iptables right here. So notice it's off for run levels 0, 1, and 6. So when the computer goes into run level 6 to turn the computer, to restart the computer, or 0 to turn the computer off, it makes sense that it would turn off the firewall, right? But when we go into run levels 2, which is rare, 3, which is common, 4 doesn't really exist for us, and run level 5, it turns it on. See this? In other words, if I look for the Iptables command, and actually I don't know if it'll show up with a, yeah, it doesn't show up as an actual running process. But anyways, just trust me, Iptables is running. Okay, I'll show you this as an example in a second. So if we look just at Iptables, I did the -- list command. We can specify. It says when the computer starts up, Iptables should be on. But what happens if I just say, well, I need to turn Iptables off right now? Well, here's what I can do. I can do a service, Iptables, stop. Look what it said. It said it flushed and it stopped Iptables. So now Iptables is stopped. But if you look, it still says on right here. And the reason it says on is because we're talking about two totally separate things. This is talking about when the computer goes into run level 5, for example, or run level 3, for example. It turns it on by default. But if I need to manually turn it off, I have to use the service command. Okay? So another example. Let me look for cups. I think that will show up. Okay, good. So here's my actual cups daemon. This shows that cups is currently running on my computer. Okay? If I do a chkconfig for just cups, notice it says that's correct. I'm in run level 5, so it turns it on. Okay? So let's do this. Let's do a service cups stop. Okay, so I stop my cup service. I'm going to run a status command, service cup status. It tells me it stopped. Makes sense, right? But if I do another check command, or chkconfig command for cups, notice it still says it's on. That's another example. So in other words, even though cups is stopped right now on my computer, if I were to reboot and go into run level 5, it would be on. It would turn it back on. So the service command is used to start and stop services right now where I'm at on the computer. But that doesn't affect how it, by default, when the computer loads. That is handled through the chkconfig command. So let's say we need to change that. Okay? Let's go ahead and change it. So chkconfig, and then here's what we can do. I can do level, actually, I think it's this one. I'm working on this from memory. Let's say we want to turn cups off by default for run level 5. So I do chkconfig cups, and then we're going to tell it level 5 off. Okay? Now watch what this did. I'm going to do another list command, and now look how it turned it off. Before it was on, and now it's off. See that? But it left 3 alone. 3 is still on. See how that works? If I don't care what run level, and I just want to turn cups off altogether for any run level that starts up, I could just do this: chkconfig cups off. And now watch what it'll do. It's off for level, well, it's for all of them. Look at that. For 5, 4, 3, 2, and 1. It's off for all of them. If we want to turn it on for all of them, then I would just do chkconfig cups on. And then look. It's on for levels 2, 3, 4, and 5. It's off for 0, 1, and 6, which makes sense, right? 0 is shutdown, 6 is reboot, and then 1 is single user. So see how that worked? Now again, everything that I just did right there has no effect. Let me go ahead and turn it back off again. Or on. Actually, let's leave it on. Okay, so it's on. Has no effect on whether cups is running right now. It's all for startup. Service cups status, and it'll still say it's stopped because I stopped it right now. But if I reboot the computer and I go back into run level 5, then it would start it again from scratch because it's set to be on by default. See this? So I hope that makes sense. The chkconfig command can be used to see everything. It can be used to see just a specific one for snort, for example. So you see, actually it's hard to see. Let me clear the screen. So just one. It can be used to turn an on or off for a specific run level, for a specific program like snort or a specific service, or we can just turn it off or on for all run levels for a specific service. So that's how that works. You'll play with all of that in lab, and hopefully that will begin to make a little bit more sense. And then the service command is used to stop, looks like it's already stopped, or start a specific service. Well, it failed anyway because it's not correctly configured. That's a bad example. So service cups start. So the service command is used to start or stop a service right now. Okay? So that finishes out this lecture. You need to go and watch this, make sure you understand this, probably watch it a few times, make sure you kind of have a grip on it, and then we'll go into lab and we'll practice all of this all over again.